So, introductions. I am the this year's Observe Wonder Think coordinator. My name is Esther Hines. I'm a former classroom teacher and related to Beyond Benign for many, many years. I'm going to share with you some notes and meetings protocol. So we welcome and encourage you to turn your camera and microphones on, especially during our collaborative portion, which will not be recorded. We are only recording the presentation portion, but we will be monitoring and sharing a great deal of information in the chat to be inclusive and to encourage engagement. We would love to learn a little about you too, so please tell us what you would like to take away from today's session in the chat and introduce yourself if you haven't done it already. Additionally, we ask that you rename yourselves to the name you would like to printed on the Professional Development Credit Certificate of Attendance. This also helps us understand who our audience is and where they join us from. Thank you. So now our topic for this evening is chemical management and safety, and our presenter is Sarah Briggs. Sarah is the program manager for green chemistry and emerging contaminants at New York State Pollution Prevention Institute at Rochester Institute of Technology, where she executes green chemistry initiatives and conducts research focused on the reduction of toxic chemicals in products and industrial applications. Before joining New York State Pollution and Prevention Institute, she held positions as a research chemist, educator, and environmental health and safety specialist. Ms. Briggs holds a Master's in Science in Chemistry from the University of Minnesota Twin Cities and a Master's of Art in Chemistry, Bachelor's of Art in Chemistry and English Literature from Wesleyan University. Ladies and gentlemen, here is Sarah Briggs.
Thank you. All right, so let me share my slide. Okay. Can everyone see the title slide?
Yep. Yes, thank you, Sarah.
No, thank you. So as Esther mentioned, I will be talking about chemical management, safety, and some pollution prevention strategies, particularly focused for high school chemical inventories. So in case you haven't heard of the New York State Pollution Prevention Institute, I just wanted to, give this little overview slide. We are headquartered at the Rochester Institute of Technology in New York, and we receive funding through the New York State Department of Environmental Conservation to work on a broad variety of areas related to pollution prevention and sustainability. So we've got these focus areas that I've included here. And at the bottom, there's the Green Chemistry and Emerging Contaminants program, which I manage and is related to what we will be talking about today. I did just want to make a brief disclaimer about the topic, specifically since we're talking about chemical management and laboratory safety. Both of those things, right, have a variety of different regulations that may apply based on where you live, what country or what state you're in. And so I'm speaking about this from my own personal experience and giving an example of how to approach these topics. But if you have a specific question related to, a specific problem for lab management safety, especially related to compliance, I just want to make sure that it's clear that you need to reach out to people in your specific locality because different regulations might apply at different places. All right. So this is kind of a daunting topic. I referenced that with my title, but, talking about chemical management, especially for high school, chemistry teachers or other high school science teachers, can be a little intimidating and feel a little bit like we've got inventories, we've got the stock room, we've got the hazardous waste. If I can't pour it down the drain, what do I do? And you're trying to do that on top of already, teaching your students, writing your curriculum, grading, monitoring behaviors, and it's a lot to get at. So we're going to try to go over a high level, and if there are some questions, we can, delve a little bit more into them. But I'm going to kind of speak from my experience, both, implementing chemical management at both a K through 12 and higher ed level, as well as being a safety specialist and working with labs to, do this better. And then I also just want to touch on the fact that green chemistry is really a great tool for pollution prevention. And I don't think we, necessarily realize that, especially not in general chemistry education. But we'll touch on how that kind of applies to the work we do with P2I. And all of this is just going to underlie, what are the best practices we can use for safety when we approach chemical management. So I won't be, really calling out too much safety, but just kind of peppering in how does it fit. So the first thing that you should think about when you're approaching chemical management is your chemical inventory, because you can't manage what you don't know. And that can be kind of daunting because, depending on where you are and, if you just arrived at a school, if there are multiple chemistry teachers or not, right, your inventory may already be done. It may be non-existent. So this is just an example that I've pulled from some of the New York State Department of Environmental Conservation resources for school management. It's a chemical inventory worksheet template, but there are a variety of ways you can do this, and essentially you have to figure out what do you have on hand before you can manage it. And this is probably my most safety-heavy slide, but when you conduct a chemical inventory, I cannot stress the importance of wearing your personal protective equipment and really approaching the situation with a safety mindset. So everything that you would tell your students in terms of if you're handling something hazardous, we're going to have a full lab coat. All of your, skin should be covered, especially your pants, no rips, like cover your toes, because generally, especially on a first pass inventory, you're getting into the weeds of, I don't know what's in this stockroom, or I know what I use, but I don't know what this other stuff is. And so you want to keep safety at the forefront of your mind when you're handling things that you're maybe not sure what it is. This is a very enthusiastic me from college way back when. It's very fun. Go safety. Also, I did crop my buddy out because I don't know, I didn't get permission to put their face in this presentation, but as you can see, there is someone next to me. And if you are doing your chemical inventory, always use a buddy system as well. You don't want to be doing this by yourself. It's also a great, way to maybe do this as like a professional development opportunity with other teachers. I know when I was doing this for my K through 12 school, we did organize chemical inventory as a professional development day. We planned it like our principal knew what was going on. And so there were plenty of people who were aware of what activities we were getting at, because sometimes there are safety hazards. And so I have this lovely photo here, which is not what you want to see, but can happen. And so I want to just enforce that, when you're opening cabinets that, especially if this is a room you haven't been to, if you can see there are crystals on the bottles to the right a little bit. This ended up being fine. It wasn't a problem, but I put it up for the reason that some, bottles of like things like ether can actually form shock sensitive or like explosive things, which as a safety professional, we always tell people if you find something that is compromised, if it has crystals on it, if it's leaking, like don't touch it. And my personal experience was when I was, again, teaching in high school, we were doing a chemical inventory. Everything was going fine. And we get to the bottom of the chemical cabinet, and I found a box with a bunch of radiological hazards on it. And at that point, I put the box down and I told my coworker that we were no longer doing the inventory. And we went and talked to the principal of our school because I was like, I don't know how to handle this material. I am, I don't feel safe or like I'm qualified to do this. And because we had, again, looped her into what we were doing and we had a good relationship with her, she was able to reach out to the district, who actually got in touch with the Department of Health, and they came and they assessed the situation. took care of it. It ended up, they were tiny test watches, so it wasn't really a problem. But I say this to empower, teachers who are maybe doing this, that don't put your safety in jeopardy. If you're coming on something like a bottle that's got crystals on it or that's broken, you probably didn't generate the issue. You may or may not be qualified to handle it. And so really, I would highly encourage you to reach out to either your admin or someone in your district to help you, because it's a risk that you shouldn't be taking on. We want you to be safe and come back and still teach your students. So that's the worst case, is you find something you keep. But mostly, let's assume your inventory is going great. You're getting things, you're deciding, okay, this is what I want to keep, this is what I don't want to keep. And you don't have to do anything fancy, but like having just a regularly updated Excel file can go a long way, because if you, do your initial inventory, you say, okay, we now know this is what we have in, maybe you just have a stock room, maybe you have multiple, right? Not only do the teachers now know what's on hand, which they might need for like planning purposes and actually executing their curriculum, but then you can share that information with other people in your building, particularly, again, like maybe the main office with the principal, or like the greeter if they have to have it there. So if something happens, maybe on a weekend, if there's an emergency or a flood, right, it's saved in another location. Other people know what's in the building. Facilities is another group of people who might want to know. And so that's one of the, benefits of doing a comprehensive inventory, is that you can actually manage what you have and make plans for if something happens, so that you don't have to, worst case, show up and go, we have no idea what's on the floor, and now we have to treat it as an extremely hazardous event. If something goes. So this is a list of things that you should include. I will call out that the chemical name here is specified as spelled out. So using the actual letters, not a chemical formula, is helpful, because especially people from like facilities, or if they have to have someone come in from the fire department, right, they're not going to necessarily know how to read a chemical formula. So you want to make sure it's written out that people can read. CAS numbers are extremely helpful for pulling up SDSs, and then, warning codes, or how much you have. But depending on where you are, again, I put state, but I don't know, it could be different for different countries. There should be actual guidance for what you're required to actually keep on hand for the chemicals you keep in your inventory. And the other, last nice thing is that this helps with like transitions. So if people retire and you have new people coming in, right, and you're maintaining it, it's easier to know what you have, rather than being like, we don't know where that chemical went, or how we got it, or, which can happen. So then moving on to the stock room and actually storing said chemicals, right? You've done the inventory, you've presumably sorted your chemicals into, I want to keep them or I want to dispose of them. So first we're going to talk about the chemicals you actually want to keep and you want to store. And I, can't say this enough, but do not store your chemicals alphabetically. My mother loves to store my spice cabinet. Like, she loves to organize it alphabetically. It makes everything really easy to find, and that's wonderful for cooking. But it is not great when it comes to, again, hazard management and safety with your chemicals. And I do get that it's really helpful. Like, I used to, when I was in undergrad, we had a demonstration laboratory and all of our chemicals were aligned alphabetically. It was very easy to find them. And now looking back, I'm like, yeah, we shouldn't have done it that way. But you learn. So the thinking behind that is, there are many different types of chemicals. Here I have the GHS hazard classes, right? And we know they're not all the same. So if you line them up alphabetically, presumably they would be fine. But in the event that a shelf breaks, something, like a light fixture swings down, like if they spill, if there's any sort of, again, like a pipe leak and something gets out, right? Now we're concerned that we might have incompatible things that can react together if for whatever reason their containers are compromised. So you can try to sort your chemicals in a variety of ways. There's no one method that is perfect and or, required, because just the amount of chemical incompatibilities is like so extensive. So there are a couple of them listed here. I've never personally used the color coding method. It's based on actual like colors that the manufacturer will put on the chemical containers. I've really never found it applicable because I usually have such a wide variety of like sources of chemicals in stocks that I'm working with that not all of them have their colors. Like they'll have flammables have like a red designation, or health hazards have a blue designation, right? If you don't have that many chemicals and they do color code, that's an option. When I was working as a laboratory safety specialist, I often would recommend that people started off by just looking at the GHS hazards and saying, okay, which hazards do I have? And that's not foolproof either, because, you might be like, well, I've picked up bottles that have like 2 or 3 GHS symbols on it. And like, how do I sort them? So it is tricky because you have to actually look at the chemical that you're handling and say, okay, I usually would tell people, is there a physical hazard that, is it flammable, or is it an acid or a base? So it really needs to be physically separated. And then, those things also might be toxic or might be a health hazard, but you kind of have to individually go through and rank which of these is more of a concern, from a storage perspective, rather than like if it's acutely toxic and you're not supposed to eat it, good to know, but maybe not as much of an issue from a physical concern standpoint. The Flynn inorganic and organic grouping codes is kind of similar to the color coding method, but I have used it. It takes up a lot more space in terms of the chemicals come with a code. It's either an I or an O and then a specific number. And basically they've organized, I2 corresponds to a certain subset of inorganic chemicals that should all be compatible. And I think the only drawback for that from a high school perspective particularly is that sometimes it requires more space than stockrooms tend to have. They tend to be pretty cramped in my experience. And, if you've got like 12 different categories that you're trying to sort out, that can be hard to separate. So, try your best to pick one. The DEC resource that I had linked on a previous slide that I also have at the end in the resources slide has a really wonderful table of incompatible chemicals and potential hazardous reactions. So I would recommend, getting an assessment of what you have, picking a certain organizational strategy, and then cross-referencing with a table. Excuse me. All right. Additionally, you should have safety data sheets on hand for every chemical in your stockroom or inventory. Oh boy, my voice is going. Excuse me. These should be within the immediate vicinity of the work that's being done. And I like to use a binder, which you can organize alphabetically. So you can't do it for your chemicals, but you can for the SDSs, because in an emergency, if you need to grab an SDS and take yourself or a student to the hospital, right, and you need to say, I need the SDS to take to the emergency room because they won't know what the specific chemical is, you're not going to be like sorting through by cast number. You're just going to want to be able to open the binder and say, this is what happened. Here's the information, and give it to them. You can also keep these electronically. I think that's also recommended. I like to have the second set physically printed out on hand. And like my students would have to, they'd have to do their like safety pre-check before we did any labs. And so they'd have to say, we know where the fire extinguisher is. We know where the eye wash is. We know where, the fire, blanket or whatever. I'm trying to think what else we had. But you can put this either by the door to the stockroom, you can put it by the fire extinguisher, put it somewhere though where students will know where it is. It's easily available to first responders if they have to, show up because there was a fire or something and they're trying to get information. And then again, having those SDSs also stored electronically is just really good housekeeping, and helps in the event that there is, hopefully not an emergency, but we plan for these things so that we never need them, ideally. A couple of last things I want to highlight for storage. If you're lucky enough to have a fume hood, I know not all high schools necessarily have them, or maybe they only have one. I just would like to reiterate that they are not for storing chemicals, because if you have things in your fume hood, you are actually going to impact the flow of the air that's being essentially like circulated to suck any fumes up and protect you. So resist the urge to store things in them, but you can definitely use the cabinets that are underneath. It's a great way to sort out acids, bases, or solvents, especially like solvents that you're worried about maybe if they stink or something. I know people put things down there. But just make sure you keep the fume hoods themselves clear as much as possible, because then that keeps you safe when you're using it to actually prep things. I know it seems like it goes without saying, but separating acids and bases is really important. I have talked to people who are like, I have my stuff under the hood and it's great. And I think they look at it and they think they're both corrosive. So they're like, yay, I've got my hazards together. But right, if they mix, they neutralize each other, give off a lot of heat, and that can potentially be a problem if they're near other things. So we always recommend keeping those separate, and just making sure your chemicals are stored and locked away when they're not being used so that students can't access them. So those are pretty easy. And then don't forget to reconcile your inventory, usually at least annually, which means basically go through and check, does your inventory match what you still have in your stockroom? Because if you do this every year, maybe you'll say, oh, we ran out of this, or oh, we bought this new thing, and you add it on, and it keeps things much more up to date than if you just do an initial inventory and you don't remember to update it. And this kind of prevents you from getting into that situation that people started with, where they're just like, we don't know what we have on hand. Now, the other option, which is we have things we want to get rid of. And I couldn't help myself, so I had to put this meme in here, because this is the face that I get when I talk to people about hazardous waste. And it's usually, there are two options, which is either I ask them, like, what are you going to do with it? And they go, I don't know how to get rid of it. But more often, and this is the more concerning one, I get that I don't even know what that is. And in the unfortunate event that you've inherited something, right? I'm not sure, but some people maybe have had that experience where you get this lovely unknown. Those are really painful and annoying to get rid of for hazardous waste haulers. So my top recommendation for managing hazardous waste is to label your waste. Because even if you don't know how to get rid of it, you need to know what you are getting rid of. And this will prevent unknown waste containers. And we're all human. Obviously, no one is, saying, oh, I want to leave waste behind and I didn't mean to take care of that. But like sometimes things slip through the cracks, especially if there isn't a well-established disposal method for, people, especially schools, like you're kind of on little islands. So you will save yourself and every person after you a lot of headaches, and frustration if you just make sure that you label your hazardous waste containers. They, basically we call them, hazardous waste manifest. And these are just bare minimums. Again, like regulations and requirements may be more specific, but you should include the date that the container was started, the name and contact information of the person who's responsible for it. So for a teacher, right, you would usually be the person who's running the lab and generating that waste. The name of all of the chemicals that you're adding to it. Again, you want to write those out, not have them written as chemical formulas, and approximately how much of each chemical you have added. Because it is a pain in the butt, but it will save you a lot of trouble after the fact if you really document that very well. And I would even recommend when you're planning or coming up with new lab activities to really not only be like, okay, if we're doing a reaction and it's going to generate this, but then to also take the next step and say, how do I dispose of it? Because your disposal options are going to be dictated by, again, federal, state, and local regulations, and also what type of waste you have. So specifically for teachers, right, we're mostly talking about laboratory chemicals, and you can try to find that information on the SDS, which I did chuckle a little bit as I wrote that down, because we've probably all looked at SDSs of varying detail. So that might not give you much information. My favorite phrase is the refer to state and local guidelines for additional information. It's very helpful. So probably you might have to reach out to someone at your district who manages environmental compliance. This might be someone in facilities. There might be a dedicated environmental health and safety professional. I know depending on the size of the district, how well funded they are, that might be different, but there generally should be someone who manages this, because they'll also manage things like paint, pesticides. All of those things have to be disposed of in specific ways. For laboratory chemicals, though, often what's going to happen is they are going to require that the district actually contracts an independent waste hauler who has the right Department of Transportation and environmental certifications to move and dispose of hazardous materials. So if you plan out your labs before you do them, and you try to get ahead of it, you can actually figure out, okay, if this has to be disposed of as hazardous waste, what would be a quote for disposing of it? And that can sometimes be like a nice way to talk with your admin about, I would like to do more green chemistry. We'd like to get more funding for that. They might not understand like a why. And this would be a good way to say, hey, we've been doing this historical, lab from the last 20 years, but, did you realize when we dispose of this, this is how much we're paying, or this is how much we would have to pay to get rid of it. So it's a nice economic angle on top of safety and stuff too, but we can talk more about what that looks like if anyone has questions. Usually they lab pack small laboratory chemicals, which is a thing. So lastly, I'm not going to get too much into pollution prevention through green chemistry in terms of specifics. A lot of stuff that, Beyond Benign does also focuses on implementation of green chemistry, but we do a lot of it because, waste prevention is one of the 12 principles, real-time pollution prevention, and a lot of this stuff that we really are trying to encourage with adopting more green chemistry in the classroom does end up, even if it's not directly but indirectly impacting, what we call source reduction, where we are just using less of things that can potentially be a health hazard or an environmental hazard. And I just wanted to highlight my favorite that I have at the moment, because I remember in high school doing, acid base and using indicators, specifically phenolphthalein. I used universal indicator all the time in college, and I just, for fun, pulled the SDS for phenolphthalein, which is a skin irritant, germ cell mutagen. For those of you who don't know what the number rating means, a 1B for a carcinogen is a probable carcinogen. Basically, it's reasonably assumed to be a carcinogen. And I was like, oh, this makes me a little sad, because I don't know that I would have wanted to maybe play with it despite it being a very pretty color as a high schooler, if I knew that that's the hazards that were associated with it. And if you've seen any of Beyond Benign's other demos and some of their work, they have this awesome alternative, which is butterfly PT. And I pulled this very beautiful picture off of a T-Bar's website because you get this amazing color change with something that, your students could literally drink. I would also like to say my students always used to be like, can we taste test that? And I was always like, no. But it is nice that, in this case, technically it wouldn't hurt them to drink the tea if, there's an accident. So I just think this is a fun example of really, though, all of the opportunities we have with using creative green chemistry alternatives to do the same sort of things that we would do in a high school lab, but now rather than having a solution that's got phenolphthalein in it, you can just use the butterfly pea. And with that, I will say thank you, and please let me know if you have any questions.